Welcome to this EGU press conference. Today it's about archaeopedology, and it's kind of special because it's the first time that archaeopedology is in session on the EGU Congress. So Luca Trombino, he's from Italy, he will tell you something general about archaeopedology, and then afterwards Maria-Raimonda Usai and Andrea, Balbo and Stephania will give a short introduction of their new findings. So go ahead.
Thank you very much. So about the session 30, Soil Archaeopedology and Archaeological Soil Micromorphology, I have the pleasure to organize together with Martin Gerard, which is in the room, and what we are dealing with. We are dealing with archaeopedology, a discipline in which we try to apply the soil science know-how and techniques to the archaeological research, to the archaeological field. And then the second soul of this session is a special method of studying. It means archaeological soil micromorphology, studying archaeological deposit and archaeological soil in thin section at the microscope. To do that, we need a special kind of sampling, a special kind of preparation, it has impregnation, and then we can have thin section to look at the microscope. Why we can put an archaeological session inside in the soil system division of the EGU? Because we start to consider the human influence on soil exactly as the other genetic factors. Humans start to influence the environment and soils since 10,000 years, more or less. But we were very effective. We do things like deforestation, reclamation, terracing, agriculture, and so on, urbanization, for instance. And then specialists can read traces of such things inside the archaeological deposit. How we can help the archaeologist? There are four main topics. Most of them are represented in the session, just a short introduction. The first one is help in paleoenvironmental and paleoclimatic reconstruction. Archaeologists need to know how was the world at the moment of some culture was developing. In this photo, just for example, we have an old river flowing once, and now is between the sand dunes of the Sahara Desert. But in the same area, there is full of archaeological site. Second way to help archaeologists is to evaluate the past human impact on soils, natural soils, and environment. This is a Bronze Age site in the central Syria, in which the inhabitants build a defensive rampart 1 kilometer square. And, of course, they change the environment, the natural environment. They divert the river, they digging to have material to build the ramparts, and so on. Then another help is the evaluation of site formation processes, past human activities. For instance, in the photo is from a Neolithic site in northern Italy, is a so-called Polynesian oven. I mean, it was from the Neolithic in Italy, but now we know such a structure in the Polynesian culture, way they used to cook entire animals for eating. Sorry. And last way to help archaeologists is evaluate the last steps of one culture. I mean the abandon of site. I mean when there is some problem, some change in nature, who is hostile to the mankind, and there are some changes. For instance, Bronze Age site from northern Italy, all the holes are wells for water. The water was disappearing, and so people start to dig a lot in order to find new waters. And when the waters was completely disappeared, also the people disappear. For me, it's all. You will be this. Okay. I pass.
So do I move in there or do I move them?
I don't.
The computer.
Okay.
I think I need to see it. So how do I find my presentation?
Nella barra in basso. In basso. Nella barra. Sei già aperto. No, the other one.
Questa?
Sì. No. Right.
Questa. La prima?
Quindi slideshow. O F5 ha detto di caricare. So I'm Raimonda Usai, and this works. Usually, as Luca said, soils can tell a lot about archaeology, but usually when people study human graves, they throw the soils away and they don't do anything. Particularly, they don't use the technique Luca described. And so this work is to prove that, the techniques Luca described are really important to understand what happened to in archaeological burials. So this is a site in Yemen, and this is a sandstone cliff, and as you can see, it's got a lot of holes in it, up there and up here, and these are called crevices, and inside these holes, you see these are your colleagues, these are journalists who organized this expedition, because inside these holes there are mummies. How do I go down? Page down? No, mummy. So this is a mummy, for example, which is from the Iron Age, about, I think, 2,000 or 3,000 years before present. And it was found, and this is that's up, to go up. Previous one. Okay. Yes, so that mummy was found into one of these holes, but one of these holes was empty and there wasn't a mummy inside, but the hole was still there. Grazie. Yeah. So this is the section, the profile, so the way these holes in the cliffs looked like, they had a little wall covering them and another wall covering them, and then in one of them the actual mummy wasn't there, but it was all covered by layers. You see, these are all layers of soils. And in the second grave, the mummy was there, and it's the one we just saw the picture of. So what we've done, basically I've taken all those soils and I applied all these methods together. One was microscopy, micromorphology, as Luca just described. The other one was the X-ray diffraction on the soils covering the mummy, and the other one without mummy. And the other one was gas chromatography and mass spectrometry. So we got incredible results. This is one of the thin sections that shows, this is a hair, a fragment of hair. These are follicles. And this is a piece of hair inside a follicle. And so then we did, we look, oh wait, I didn't put the thing sections of back. So we looked at all these sections were covered by a very shiny material, and we looked at it under X-ray, and we found that it's very shiny material was uric acid, which we interpret as coming from avian droppings from birds. And so we think that uric acid has probably protected the mummy, we don't know. But also in the soil we found cholesterol and bile acids. So cholesterol was both human and animal, and the bile acids were definitely only human, of human origin. And also we found in the soil evidence for embalming, to preserve the mummy. So basically in one of the two graves, how do I go up? The page up. In one of these, there wasn't a body, but all the evidence I just showed you was there. So this was there, and also the fragment of skin and the follicles was there. And so that proves that these techniques are also able to identify when the body has been there but is not there anymore, because either has decayed because of time or because it's been removed. Yeah, so in one of the two sites where we couldn't see the body, there was one in the past, and it's been proved by the techniques we've used. Yeah, that's it. 5 minutes.
Right. So I'm going to briefly present some preliminary results from an excavation campaign that we're carrying out in Syria, in southern Syria, in the leisure. So the first thing I want to say is only part of a broader research, which is led by a joint team between the CNRS, the French National Research Council, with Frank Bremer, and the Spanish National Research Council with Juan José Ibáñez and a number of team members. So this was a stone building, a pretty old one. It was found by the French in 2007 in southern Syria. The French, being interested in Iron Age, they let us come in and lead the excavation of the building. So as we usually do for this sort of structures, we came in last year. The idea was to empty the building as quick as possible, well, recording everything, but empty the filling, which is normally just a simple destruction level. But we were stopped by 24 individuals, all dead. So basically we found a lot of burials, 24 people buried within 18 different contexts, which is already telling you about the complexity of burial in this house. So some are multiple burials, some present subtraction of parts of the skeleton. So the happiest person, of course, was the anthropologist. Since we found all these bodies, we decided to implement some micromorphological and geophysical analysis on the profiles. So we sampled 2 profiles, one within the building and a control profile outside the building. So we dug a second trench. Well, results first. So one of the results that we think we found was that the area was sort of homogenized before starting the burial. The burial that you see there schematized, that one, is the deepest we have. And as you see, it was the body was buried just after the deposition of this level 5 top. Now this level gives the highest reading in charcoal content, so something was going on in that area before they started burying people. On the other side, inside the building, for a similar level, what we see is that after a period of abandonment, which is layer 5 here, and then natural accumulation, in layer 4, we find a lot of building material which have not been rounded, so they've not gone around very much, and it looks, we find signs, micromorphological signs of compaction, this voids, so we think even the building was also refilled and somehow regularized before starting burying people in there. So from the soil sciences, we can say that the whole area was somehow homogenized before starting burying people. So different spaces were homogenized. But when we look at the distribution of finds and distribution of burials, what we see is that the part you see here inside the circle, you have the building and then the control trench up there. So all the secondary burials, among them there is a skull catch with 2 skulls, were found within the abandoned building, and likewise all the mobile art was found in there, while most of the primary burials were found in the smaller area up there. So we think that there was still a difference. We know that they were using the walls as a reference to go back. Well, they were burying their bodies not randomly, but always along the wall, so that they could go back to it, and the identity, that sort of issues. If you look further down the profile, the outside profile, what we find is a layer which has got no signs of building whatsoever. So we are inside a building area, and we've got an open air space, which is quite unusual for this sort of period. So what we are doing, and which is most related to this session, is to try and investigate further this level. See if we found charcoal, some are domesticated plants, and now we are preparing samples for phytolith analysis. So just to show you, what I've been showing you comes from this little square. This tomographic image, red is walls, blue is empties. So as you see, we've only just attacked one building within a complex, living complex. So we're going back next month, and probably we've got work for a few more years to do. So why Qarassa? Why this site in southern Syria? This is because, the site dates to the mid of the 9th millennium BC, more or less, which is called the pre-Proto Neolithic B. This is when we see the emergence of domestication, complex buildings, complex funerary behavior. Traditionally, the PPNB sites, or the PPNB period, has been investigated in the northern Euphrates. Now, with this new size, we're kind of stretching the focus of research for the origin of agriculture, basically, and this complex modern behavior, which is at the origin of present-day behavior, basically. So this is what we're doing in Syria. This more work is just preliminary.
Okay. Good morning, I'm Stephania. I will tell you about archaeopedology in forensic context. And why forensics? Because you know, it's more familiar in this time to hear about some forensic case like kidnapping, violence, or finding of human remains. And particular attention I have to pay to the environment in these cases, because when you have to work with bones or with a skeletonized or decomposed human body, the thing will be more complicated than not with a fresh cadaver. And you have to look for evidence, not classical, but like pollen, like fibers, like bullets into the soil. What's new? I study with the archaeopedology methods in thin section, bones, found in bones of a human, analyzed by petrographic microscopy, and I found this special coloration, color pattern that can be related to be Vivianite. Why is this important? Because we know from a archaeological context that Vivianite forms in reducing environment, rich in organic matter environment, where the matter, organic matter, supplied the phosphorus source, is a phosphorus source, and the soil supplied for ferrous. The same things can happen in a clandestine graves, because we have the body, buried body, that induced the anoxic condition with the decomposition of the body, of the soft tissue, and supplied the organic matter, rich in phosphorus, like bones, and the iron, the ferrous ions, is into the soil. So we can have the vivianite in archaeological context, such as latrines, and also in clandestine grave. That's important because vivianite can be a marker of burial of human remains into the soil. Also, if you found the bones not buried in the soil. Okay. On the other hand, we cannot state that the absence of vivianite can be an indicator of non-buried status yet. We have to study, but because further analysis have to be run to investigate the pathways of vivianite crystallization, the different behavior of skeletal district, the different time of burial, the influence of vivianite crystallization, and in different kind of soil. And we have to study with SEM and microprobe to quantify the amount of vivianite on bones to reach an amount maybe such a level of good marker of vivianite presence in burial. And do you understand me? Okay, so it's a little bit complicated. So, and why forensic in archaeopedological and so? Because we heard about burials in archaeology, and because archaeopedology studies human influence during historical times, and I want to study the human influence on the present day forensic context. So the soil, for its variability or in horizontal and vertical dimension, could be a good evidence and can contain a lot of evidence. So can be a great potential to study in forensic context. But all this a different scale of observation, because we use stratigraphic methods to excavate for excavation in archaeological burial, but also in a forensic context when we found human remains in a clandestine grave. We have to sample. We have to identify also the area of a possibility of a clandestine grave, and we do this with archaeological methods, like anomalies of geomorphological anomalies, and from field to microscopical level. So we have to study thin section, also not only of bones, but also of soil, to know the movement of the composition product, to look for the presence of special mineral alloctonous or very indicator of provenance, to get also a link between different soil, because you are asked by the police and you have to answer specific questions that are not the normal question that the archaeologists are normal answering. Okay, that's all. Thank you.
Right, thank you very much. Are there any questions? Yeah.
Stefano Tanzani from Nature Publishing Group. Presumably there's a tension between you guys and the archaeologists, because you guys like the top player, and the archaeologists want to get to the bottom of the thing. I mean, to discover what's inside, basically. How long does it take you through the analysis, and I mean, to take your samples of the topsoil, basically, in archaeological sites? I mean, if you can generalize for every context, I guess.
How long it takes to get a sample?
Yeah,
well,
samples
and work on it. Well, take a sample. You just they call you. You go on the excavation. You can do it as a consultant or as team member. So in some cases, you're there from the beginning of the excavation. Taking the sample is very quick. I would say there is a rate 1 to 4 maybe in terms of time, the time you spend on the field and the time you need afterwards. There's a lag in time on thin section production. There are very few labs around producing thin sections, so there's between say 2 and 8 months least normally, which is about the same you have with radiocarbon dating, depending on the. And another thing to consider is that it's also, I mean, archaeologists often think that micromorphology alone or soil soil study can solve the whole issue, but it's actually really, I think, part of a interdisciplinary approach to. So it's an add-on, is like wiggles that you add for a paleoclimatic reconstruction. So it's some extra data we give. Exact time. Well, the results I presented, for instance, are very preliminary. We went out last year for the first time. It took them 5 months to produce the thin sections. I've only looked at them very quickly. I've got them 3 weeks ago, so there's more work. But after this first step, you decide where you find the hotspots, and then you collaborate with other specialists, phytolith, charcoal, and trying to get in depth.
All right, then I would like to thank you very much. And if you want, the session will be today at 3:30 in room 8. So good luck with your further research.
Thank you very much.
Thank you very much.